Hello everyone. We're going to learn how to compute probabilities of Poisson distribution in this video. A Poisson distribution is a discrete probability distribution. And if we want to express the probability of a given number of events occurring in a certain interval of time or in a length of space, we could use Poisson distributions. Things like number of calls received in an hour, number of cars crossing an intersection in say 20 minutes, number of children, babies born in a hospital in an hour. All of these could be modeled using Poisson. Poisson distribution has a single parameter called lambda. Lambda is denoted using this inverted Y. And lambda denotes the average number of events that occur in the specific interval. Say the average number of calls received in an hour, average number of children born in an hour. So the average number denotes is given by lambda. Once we know the value of lambda, we can just go ahead and compute the probabilities of the particular Poisson distribution. So let's solve a couple of examples. Suppose it takes me 10 minutes to grade an assignment. And I would like to know the probability of grading X assignments in an hour. So I'm interested in finding the number of events, number of X assignments graded in an hour. This can be modeled using Poisson. So before we actually get started, we need to identify lambda. Lambda is the average number of assignments I would expect to grade in an hour. So if it takes me 10 minutes to grade one assignment, I could expect to complete 6 assignments in 60 minutes, which is I can expect to complete grade 6 assignments in 1 hour. So we can say that our lambda is equal to 6. Now we are ready to begin. The probability of grading exactly 8 assignments in an hour can be written as P of X is equal to 8. So X here is 8 and I can say lambda is 6. And the function here in Excel is just Poisson.dist, where the first argument is the value that we are interested in, which is 8 assignments. Second argument is the lambda, which is 6. Third one is whether we want a cumulative or the PMF. Now I don't want the cumulative probability because I only want the exact probability here. So I'm going to say false and we have the answer. Let's look at the next one. The probability of grading at most 5 assignments in an hour, which is probability of being X lesser than or equal to 5. I could grade 5 assignments or 4 or 3 or 2 or 1 or 0. So all numbers 5 and below is, I want the cumulative probability for all of them. So this is in a very easy form that I can ask Excel to find. This is Poisson.dist, 5, mean is 6. And I want to say true for cumulative and compute the answer, and that is about 44.5%. Let's look at the next one. Probability of rolling at least, this is not rolling, but this is grading. My apologies. Probability of grading at least 7 assignments in an hour can be given by X being greater than or equal to 7. And I could write this down as 1 minus probability of X being less than 7. Or in other words, 1 minus probability of X being lesser than or equal to 6. And once I'm able to translate an expression like this into an expression which has a cumulative distribution form that Excel can easily handle, then we are one step closer to solving the problem. So in this way, so let me make this a bit wider. Yeah. So here the answer is 1 minus Poisson.dist, 6, 6, true. And the answer is 0.39. And that is how you solve the first question. Now let's look at the second one. Now you'll be able to follow each of these functions and the notations. If you've seen the binomial distribution video, then these should be fairly straightforward. I'll just solve the first question in the next one, and I'll leave the rest up to you as an exercise. So we're looking at a switchboard in the Minneapolis law office, which gets an average of 5.5 phone calls during the noon hour on Mondays. Now, let X be the number of calls received at noon. And I could, if it's a number of calls received in the noon hour, we could use a Poisson distribution. So before we proceed, we have to check what the value of lambda is, which is the average number of phone calls received during the noon hour on Mondays. So when we are given that that is equal to 5.5. So the lambda is 5.5, and now we're ready to begin. What's the probability that the office receives at most 6 calls, which means probability of X being lesser than or equal to 6. And now we can just go ahead and compute this as 6 calls, mean is 5.5, and I'll say true. And the answer is 0.686. So I will allow you to do the other ones. And what I'll probably do is leave these down as answers here for you to follow and check up. So I hope this has been helpful. I'll see you in the next video.